This thing is like super easy to read, and here's why. It says here, learners in a primary school are tested to measure how good their fine motor skills are. Okay, let's pretend we know what those are. I don't know. What are fine motor skills again? Are they like how well people are able to, like, I don't know, move their hands and their feet and their what? Guys, now I'm literally pausing this thing here to like Google what fine motor skills are. Like, I'll be back. Let me go Google it quickly, because yeah, ne? Hunzima. Okay, so fine motor skills is the coordination of small muscles in movements usually involving the synchronization of hands and fingers and the eyes. Okay, I guess I was almost there, you know. But that's not our concern here. So it says here, yeah, they're just testing how good they are with fine motor skills. That's not going to affect the question though. And then it says here, the results of a standard test for fine motor skills follow a normal distribution with a mean number of 10 points. So take note of this mean number. Mean number of 10 points, standard deviation of 3. Now, before we look at the question, please take note of the fact that this symbol here means mean. You see, that's why it's color coded in green. Might as well color code the standard deviation in another color. Let's give it a blue, classic blue for these courses. So this is your standard deviation. It's a 3. Wherever you see this tiny thingy here that looks like a 6, that's your standard deviation. You see this thingy here, that's your standard deviation. So what they're telling you is that if you're going to interpret this data here, this is what they mean. The mean is 10, right? So what they're telling you is that 34% of your people are 1 standard deviation away from the mean towards the left, and then 34% of your people are 1 standard deviation of your mean towards the right. That may sound like some gibberish, but watch this question for 2 marks. It says here, if a learner is selected at random to take the test, calculate the percentage of learners that will score more than 16 points. So we need to calculate the percentage of learners that will score more than 16 points. So what you're trying to think to yourself is, people that will score 10, right, at the most, people that will score 10 at the most, it's going to be 2% plus 14% of the people plus 37% of the people. That's the amount of people that will potentially score 10 at the most, because you see our mean is 10. Our standard deviation is a 3. So we know that the mean plus your standard deviation gives you a 13. So people that would score a maximum of 13 points, it would be these plus these plus these plus these. The reason we're saying those 4 sets of people is because you see our mean is 10, our standard deviation is 3. So 10 plus 3, this gives you a 13. So people that would score a maximum of 13 points, this is the potential number of people. Now here with our question, they said if a learner is selected at random to take the test, calculate the percentage of learners that will score more than 16. So we know that scoring more than 16, we have to consider this portion here, because this portion here, mean is 10, right, plus 2 standard deviations. Remember, 2 standard deviations is like 2 times 3, which is a 6. So 6 plus 10, this is a 16. You see, everyone here going to the back, this is everyone that scores less than 16 points. And then obviously everyone after that is people that score more than 16 points. So here if they're asking, if a learner is selected at random to take the test, calculate the percentage of learners that will score more than 13 points on the test. So for 2 marks, literally all they want you to say is 2%. You see, because obviously in this direction, just 2% of the people are likely to score more than 16 points for your test. Now, looking at the way this is like laid out, you may be thinking to yourself, what? Really? Is it that simple? Yes, it is relatively that simple. So obviously in terms of calculations, you can basically just showcase that you know that your standard deviation plus 2 gives you 16, which is how you got the 2%. So here, your standard deviation If you add it to your mean, you see, your mean plus 2 standard deviation is just 10. This is giving us 16. And you're seeing that 16 points starts here, you see. And everyone that's going to get more than 16 is to the right, because everyone to the left is people that got less. So with this follow-up question, right, it says here, if 200 learners took the same test. I think I should actually move it up there, to be honest, because yeah, this is just ridiculous. Look at that, I have moved it, ha ha ha. Anyways, so it says if 200 learners took the same test, how many learners would score less than 13 points on the test? Let's read this nicely, because this kind of equation is super simple. It's straight to the point. Let's not complicate it. If 200 learners, so now we're dealing with 200 learners in total. Now we have the actual number of learners, 200 learners. If 200 learners took the same test, how many learners would score less than 13 points? So if you look at your data, 13 points would lie here. You see, so everyone to the right is more than 13 points. Everyone to the left is less than 13 points. So here they're asking what percent, if 200 learners take the test, how many learners would score less than 13 points? So obviously, if we're considering scoring less than 13 points, we're looking at people in this direction. So scoring less than 13 points, you want to think to yourself, okay, this is where 13 points lies, you see, because it's 10 plus 3. That's where 13 points would be. So your people there, you want to think of what percentage of people those would be. And clearly, before you can work out the actual number of people, let's just work out the percentage first, which would just be, these percentages all added up would give us 84%. So people that would score less than 13 points, it's basically 84% of these 200 learners. So here we can then say, therefore, 84% of 200 learners. Obviously, in your calculator, you can just put the 84 with the percentage symbol times 200. Let us see what this gives us. Why do I keep doing that whole RC thing? Let us do this, do that. It's really kind of weird. I'm actually wondering why. Like, goodness. Let's hope I'm still normal. This is like 168 over here. And then, there you go. Free marks, people. Free marks. That's all they want you to do here. If 200 learners took the test, how many learners would score less than 13 points? You see, 84% would score less. So obviously that's 168 learners. If they said how many learners would score more than 13, then you would just add these two percentages up and then use those in your calculations and stuff like that. But anyways, that's that for this portion of this chapter, because you see, we're trying to showcase how to use stuff like this to showcase that it's really not difficult. You need to calm down and yeah, man,